in the previous video, I gave you an example, so now it's your turn to have a go. So, given y equals this thing here, find the two turning points of this equation here. Okay. So if you try and sketch this graph, when x is small, it wants to do this. So it will have an intercept of +2. So let's say this is 2 here, and it will want to have a gradient of -4. So -4 going downhill here. And when it's big, it wants to do a positive cubic. So it wants to do a positive cubic like this. Okay, so you would guess it to be something like this, and then hang on, and then all the way down here, and then to do. So you would guess it to be something like this, and somewhere in the middle, it wants to do a negative quadratic. So maybe give it a little bit of a negative quadratic like this. And now it's just guesswork, joining up all three parts here. So you would guess. Remember, you could guess it like this, or you could guess it like this. So it could go beyond the x-axis, or it could be above the x-axis. Let's just guess that it goes beyond the x-axis. We will find out later on for sure. Okay, so at the moment it's just guesswork. So our graph will look something like this. Now your job is to find out the coordinates here. Your job is to find out the coordinates at this point and the coordinates at this point here, the two turning points. Okay, use calculus to do this. Find when given this here, find dy by dx. Think of it in terms of the gradient. At this point here, the gradient here will be 0. At this point here, the gradient is 0. So find dy by dx and try to identify when x will make dy by dx 0. Well, anyway, do whatever you want. So your job is to find out the two turning points of this equation. So press pause and have a go. Okay, so to do this here, given y equals this thing here, differentiate it. So dy by dx will be this. Okay, so remember, this gets multiplied down here, this gets multiplied down here, blah blah blah. Well, dy by dx will be given by this. Now you want to find out when dy by dx equals 0, meaning you want to find out when the gradient will be 0. You see, the gradient 0, well, put 0 into dy by dx. So it's you trying to find this out. It's you trying to find out the values of x when the gradient will be 0. Okay, when the gradient will be 0. So this here is a quadratic. So it's just a matter of solving this quadratic equation. By now, you should be able to solve quadratic equations by heart. Either use the quadratic equation, or just do it the way that I've been teaching you, which is well, we are good at solving 0 equals x squared plus bx plus c. So because you've got this coefficient here, get rid of this coefficient. Divide everything by 12. So here you've got a block here, a block here, a block here, a block here. Divide everything by 12. So 0 divided by 12, that will give you 0. This thing here divided by 12, that will give you x squared. This thing divided by 12, that will give you this thing here. This thing here divided by 12, that will give you this thing here. So divide everything by 12, that will give you this here. Now tidy this thing up, so that will give you a third. Okay. And then now it's completing the square here. Remember, you always need. Well, your job is to zoom in. Your eyes should zoom into these two terms here. You're always going to need half of this. So a third divided by 2. So that would be a sixth here. Okay, and then later on you're going to get a sixth times a sixth. So that would be that will be 1/36. So immediately take away the rubbish and then carry this down. Now if you don't understand this bit, you've got to go back and look at the section on quadratic equations, but you should be able to solve this by heart by now. So now single number, merge these two together, so that will give you this here. Okay, so now it's just rearranging it to make x a subject. So add this block to both sides, okay, and then square root both sides. You're always going to get two solutions, and then add this block to both sides. So x equals equals this thing here. Okay, so originally when we first started, our graph y was this, y equals blah blah blah, giving us this graph, here. Okay, and remember this, when we guessed, the graph could be, the turning point could be above the x-axis or it could be below. We totally guessed it was below the x-axis, but we will find out for sure later on. So y equals this, giving us this graph here. We then differentiated it to give us this, and then if you try and sketch this graph here, hang on, let's try and sketch this quadratic here. Well, if you try and sketch a quadratic here, when x is small, it wants to do this thing here. So we'll have an intercept of -4. So this here is -4. It will have a gradient of -6. So a gradient of -6. When it's big, it wants to do a positive quadratic. So you would guess it to have a quadratic like this, and then just join up the three paths. So we're going to guess the quadratic to look something like this. You see, this turning point here should match up with this point here, and then the turning point here, it should match up with this point here. So this graph at the bottom here, you've got to think in terms of dy by dx. This here is your gradient graph. This here is your normal graph. This here is your normal graph. This here is your gradient graph. So when looking at your gradient graph, you're trying to find out when the gradient will be 0. You see, the gradient 0 is when, well, at these 2 points here, which we just worked out to be this. Okay, we worked it out to be this here. So when you punch this into your calculator, it will give you these two values here, this and this. Okay, so well, anyway, this point here is the x value here, and this here is the x value here. Okay, so now once you've got these 2 points, so you know the gradient, you know that the gradient is 0 when x. Don't forget this. Don't forget this here is also at this point here. Hang on. At this point, so the gradient here is 0. So if you draw a vertical line down here, this point here will be right here. Okay, so hang on. So this number here, minus blah 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 here, it is this bit here. Okay, and that bit there is this bit here. Okay, and also the gradient is 0 right here. And then if you draw a vertical line up here, you see this, hang on, this here is this value down here. Hang on, bear with me. It is this value here. Okay, so this 0.8 blah 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 here, it is, bear with me, just follow the track here. It is this point here. Okay, well, my point is that once you know that x, once you know this point and this point here, you can then use these two values and put it into the original equation here, which is this one here, to find out this point here and this point here. So put minus 0.379 into here. Well, put it into the original equation, and then that will give you the y value at this point. You already know the x value here, so if you put it into here, overall, well, and then also you would then put this value here into this equation here, So basically, sorry, I'm not making this very clear. Basically, put this into here, just to work out the y value, and then also put this into here and into here and into here, and then that if you put this number into this whole thing here, it will give you a negative value. So we know that the turning point here is below the negative. It is below the x-axis. Sorry, I'm repeating myself. Put this into this thing here and it will give you a negative value. So you know that the turning point is below the x-axis. Okay, and as it turns out, the two coordinates, the coordinates for this turning point is given by this. Okay, and then for this point here, the coordinates here, the coordinates for this point here is given by this. Okay.